All right, I believe we're live with no intro. How you doing, Hayden?
Good. Do you want an intro? You're here at Power Supplies with Smoking Ape and Ham Radio DX. There you go.
That works. That works. Hello, everybody watching and everybody in the chat. Good evening to you, wherever you might be. Today, we're just going to talk a little bit about power supplies. And I was fortunate enough to get my good buddy Hayden from Ham Radio DX. There's a link to his channel below, but you all probably know him. And he was able to join, and we were decided, hey, we're going to talk about power supplies with folk.
Yep.
So he just woke up, though, right?
Yeah. Probably about half an hour ago or something like that. But no, it's okay. I am aware of what is going on and proceeding, so I'm sure we can figure out something to talk about with the power supplies. So,
yeah, I think we'll do just fine. I put some slides together to bore everybody to tears, and we can go over those. So I guess we'll just start with the slides and just start talking about power supplies. We don't have to go through these in any particular order. We don't have to stick to the script or anything like that. And if there's any questions or anything, just post them in the chat. Hayden and I will do our best to keep an eye on that and get anything addressed.
Yep.
So here's slide one. Doesn't that look good? I like the gray color. You know what I mean?
This is all professional. Although John reckons it won't be death by PowerPoint. You'll learn something out of this.
Yeah, maybe. Sure. There's some people you can't teach. The other one is that I'll just apologize in advance for the attention span bros. You know what I mean? The ones that might, hey, Crusader, join the channel.
You got a new member.
How about that? Thank you, man.
Do you want to? Do you introduce and celebrate new members in ways that we normally do, or?
We can. I don't have my soundboard working correctly. So if you want to hit it with something that's not going to get me deplatformed,
have I got you sorted? You know you've got two, right?
He needs some
There was
talking about Mr. Cowley, or are you talking about?
I'm talking about Ray.
Ray. Thank you, Ray.
Yeah. Ray's also.
Got another one. So you can you still move like that after just waking up, huh?
I'll get into it. I'm a bit slow, but I don't mean to take over your show, by the way.
Yeah, but here's the thing: like when you get to be my age and you wake up a half hour ago, you really can't move like that. I got to get up and sit on the edge of the bed, and I cuss for about 15 minutes, and then I get up and moving.
Is that every morning?
Yeah, and then I do my pop and lock routine. That's where my knee pops, my back locks.
Okay. There must be a sight for sore eyes for Mrs. Ape in the morning.
Yeah, I don't think she's too happy about it. I'm usually pretty salty when I get up. And it's usually because my phone will go off, and I'll have text messages and stuff, and I can't read them because I see blurry for probably about the first half hour, 45 minutes.
It's just completely ruined for the first half
Yeah,
an hour
man,
of the
it's
day.
not good. It's not good. So the first slide I have is just really how do you power ham stuff, right? And put some language together here, and it just basically says that most amateur radio transceivers and accessories are powered from a 12-volt DC power supply. And I said most, so don't anybody get upset because they're going to be like, well, I've got a 9-volt. I know, there's stuff other than 12 volts, but the bulk of it is 12 volts. And so what I said is that many folks use what we call a power supply. And some folks do use batteries, but technically a battery is a power supply. But today we're talking about transformers, right? So something that would take mains voltage and AC current and transform that into DC voltage and current. And so what I said was that what we call 12-volt supplies are typically actually 13.8 volts of power. But everybody calls them 12, and I don't know why. Do you know why, Hayden? Hey, Chuck.
I don't know why. It's probably, I don't know. 12 volts is it's almost it is. It's a standard for like all sorts of things, isn't it? Like, four-wheel driving or off-roading, that sort of thing, So, and I actually don't know where 12 volts DC came from. I'm just assuming it come from the automotive side of things, and when they decided to put radios in cars and in vehicles, they moved to this. But yeah, I'm not quite sure where it come from, but as you said there, 13.8 volts is the standard that comes out of almost every single power supply. And even then, I don't even know where that standard come from. So
right, it's probably just easy math somehow.
Yeah, but if in doubt, just have a look in your radio's manual, and it'll say what the maximum voltage and usually the minimum voltage as well that the radio can handle. Because sometimes there's some radios that can handle quite a wide voltage range. But yeah, just check it out first before you go hooking it up to anything.
Yeah, our buddy Iowa Hank is saying that, and he's always chiming in. How you doing, Hank? He's saying that they started with 6 volts, and I think he's right.
Yep.
I thought I highlighted that comment, but I don't see it. Hey, Shane. So yeah, most equipment will work under a range of voltage, and so what, like Hayden was referencing, if you look in your manual, what it'll say is 13.8 plus or minus, and in this example, I put 5%, but it could be 6% or it could be 10%. Some instruments and some equipment is more sensitive to fluctuation in voltage than others. So, like Hayden was saying, that there's some that can handle a wider range of voltage. And it's one of the, thank you, Bradley. We're going to do a dance in a second. Let's just do that, and then I'll forget where I was. It's cutting out a little bit there.
Is it?
Oh boy,
is that you?
Here's the thing is that somebody might come along and be like, oh, look, a nice video on power supplies, and then they watch and like, oh my God, these idiots.
And then they see these two idiots. The thing is when we teach, we like to make it fun so that you enjoy it, and we don't want to be sitting here going, power supplies, you hook them up to a radio and they work.
Right.
So that's
one of the things I was going to mention though is that like a lot of times folks are using these old, and I always hate on them, the rack mount server power supplies. Mm-hmm. And the thing is you really need to be careful with any power supply you're using, especially those, because under load, sometimes they go down in their output voltage and they can drop to the point where your equipment cuts off, or even damage your equipment. And that's really something you want to avoid. Save a couple bucks on the power supply, but then end up with bad equipment. Here we go.
Do you want to keep doing dances every single time you get? Because you're getting super chats galore, by the way.
Yeah, Chrissy. Well, I mean, thank you very much. Hayden's back's bothering him, so we'll get you. We'll dance for you next time.
Yeah, we'll get you at the end.
Yeah, we'll do one for everybody.
My back's bothering me. Yeah, actually, you mentioned about. I'm not sure what you've got coming up in the slides, obviously, but you're talking about rack-mounted power supplies and computer power supplies. So they have a 12-volt output on them, but I wouldn't recommend that you use those to power radios. They're sort of current limited in how much current they can put out, and I mean you can make them work, but for your first power supply, you're better off to just get a standalone power supply that's designed to be powering radios. And there's a few different other reasons, which I'm sure we'll go into later on as well.
Yeah, and so like what I've seen is people take those server power supplies and will run them in parallel, in parallel to get more of the current that you're talking about, to get more amperage. I'm not a fan of that. And they tend to be dirty, and we'll get into that.
Yeah, and running power supplies like that too, you don't know that they're actually properly balanced as well. You might be drawing current more out of one than the other, so then one does more work than the other, and then one might backfeed into the other. So, just don't do it.
Right. So what I have is, what does a power supply do? And basically what it does is power supply for ham radio provides stable and continuous output voltage of 12 volts DC. And it's to power our equipment and accessories. Ham radio operators use a variety of radio communication devices for two-way communications with operators around the world. These devices often require a reliable source of power, and 12-volt power supplies serve that purpose. And then have a power supply will convert mains voltage. And if you don't know what mains voltage is, it's the voltage coming out of the plug on your wall. 120 here in North America. And are you 220 down there?
We're 240.
Yeah, some people will say 220 or 240, and here they'll say 110 or 120. It just depends.
Ours is 240 plus or minus 10%, so it can go down a fair way. So it's anything between 220 and 250, really.
Yeah, and then you have a 50 hertz.
Yep.
Yeah, here it's 60 hertz.
Yep.
But anyhow, your power supply takes that and then it converts it to DC voltage, and DC is flat. There's no amplitude to it, so there's. I guess just a little fun fact. So people will say, well, what kind of power supplies are there? And we're going to talk about linear power supplies and switching power supplies. They're the two different kinds, right? And then each has their own characteristics and applications. And there's some cases where one is better suited than the other. There's some applications where it doesn't really matter that much. But the main differences are really how they regulate and convert the input voltage to the desired output voltage for powering your devices.
Yeah. This is what you're going to come across when you're choosing a power supply for the first time. And as Ape said too, both have their pros and cons, but they have different applications as well. So, and we can discuss what they are. And I'm assuming you've got some stuff on RFI, which is probably the main number one thing to think about when you're choosing a power supply. So,
correct. And then James is saying if that was the case, computers would blow up. So what I can tell you is I do work in IT, and computers do blow up. You probably have seen that happen as well.
Do your computer power supplies have the little switch on the back for 110 and 240, so you can switch between the two?
Yeah, they do.
Yeah, don't flick that when it's plugged in.
It'll cause you a little bit of grief.
Yeah,
and I think we're being
but I know someone that did.
Yeah, I think we're being a little bit tongue in cheek, but the part of the problem though, James, is that if you buy a used power supply that was sitting in a data center running for 8 years straight, then you might get some degradation or performance issues with that supply. I know a lot of people will buy those used ones off of things like Amazon, for example. The other thing is that some servers are good high-end servers that'll have better power supplies than some of the cheaper ones. And like when I talk about computer power supplies, I don't necessarily know if I should just limit it to servers, because somebody will be like, oh, I've got an Acer that I bought in 2004, and then they've got this dust-filled lower grades power supply that causes them some grief.
Yeah, and just to clarify too, there was another comment by G0FVT saying server supplies are awesome for LDMOS amps. So you can use those power supplies for powering amps and stuff like that perfectly fine. I've run some transverters off of those kind of power supplies before as well. But what we were trying to get at was the starting ham getting a power supply for their first radio that sits on the bench, nothing sort of super serious like that. Because if you get it, as Abe said, you get an old power supply or something, or you get a used one, it's probably going to fail on you and cause some issues. So, and especially too if they're open rail. Some power supplies are open rail power supplies, and they're completely exposed, and you need to then make sure that they're safe, because the mains input's exposed. So
yeah, well, the other one is that they can generate a lot of noise through their switching process that can cause interference on RF, and I've seen cases where a radio is practically rendered useless because of the power supply is throwing out so much RF sound that it overwhelms the receiver, and you really can't hear anything. So just something else to consider there.
Yeah, because sometimes they have computers, power supplies will have filtering on the 240 volt on the mains input, because they're required to. But on the DC output, they might not have much or very little filtering at all, and that's because mainly too they're installed inside a PC, inside a metal box, and they kind of have very short leads, and the computer's not going to care whether it's picking up noise or not. But if you hook that up to your radio, you might see some sort of weird spurs or weird interference that you're seeing across, especially HF. So
yeah. And so I forgot to tell Hayden before the stream, but I'm going to ask him to pull up DX Engineering's website, and we'll look at a couple of different power supplies that are sold on the market. And some of the switching power supplies actually come with a tuning knob on the front of them that will move the frequency that is generated by the switching if that is causing interference on a frequency that you're trying to work. So it was a little surprise for you, Hayden. So with the first thing we're going to talk about is the linear power supplies, and we'll talk about why they're good. Then we're going to talk about why they're bad, and then we're going to do the same thing for switching power supplies. And so the first one, we were just talking a little bit about noise, but linear supplies generally produce less electrical noise and interference. And that's because it's not doing that pulsing or switching inside of the transformer. So you have a transformer, which is basically like a big piece of iron that's got a bunch of wires wrapped around it that adjusts the voltage from mains voltage down to something lower, right? And then you have to take that voltage and you have to flatten it out from being sinusoidal to no amplitude or DC current. And where they get different is how that's done. It's typically done through rectification stages. And that's where some of this noise generates. But with linear power supplies, what I have is this helps maintain cleaner signal and reduces the risk of interference from with nearby radio frequencies or things that you're trying to listen to. They don't necessarily have to be nearby. But that's probably the biggest plus to the linear power supply. They provide a smooth and continuous output voltage with minimal ripple and ensure stable and consistent power with radio equipment. So what you can get is something called ripple in your output that comes out of in terms of the power that comes out, and you'll actually still see sinusoidal artifacts, and you'll see spikes if you look at the output power on an oscilloscope, for example. And they call that interference or distortion is called ripple, and that's where different components will become saturated with energy as the power is running through there. I didn't know. You look like you want to add something there.
No, I was just agreeing with you. I was just thinking too about linear power supplies, which I'm not sure if you covered just then, but I guess the way to think about them is that they're like almost like a direct conversion. So you've got a thumping great transformer that takes that mains voltage, steps it down to a lower voltage AC, and then it's as Ape said, rectified into a DC voltage, smoothed out, made sure that there's no ripple, no noise, whatever, and then output, and then depending on, how big the system is how much current you'll get out of it. But I noticed that someone put in the chat here earlier, they said about a beginner power supply, probably the best is the linear type, which I probably tend to agree with some exceptions, of course. If you're going to be doing HF and you're worried about noise, then a linear power supply is probably a good choice for you. Although some switch mode power supplies, especially the reputable brands, are starting to get really, really good now, and you can use those for HF without any problem. They've gotten really good at getting rid of all of the RFI and, as you said, the switching noise, because we'll cover switching power supplies and how they work. But he also mentions getting one with a crowbar. I just wanted to sort of say a bit of a story about that. So a crowbar circuit is something that if the power supply, for some reason, say the regulation stage, so the voltage that's regulated at DC, 13.8 volts, if that ever failed, then you might potentially have the higher voltage, which is coming out of the transformer, directly on the output of your power supply and onto your radio. I actually had that with a power supply that I had. It didn't have a crowbar circuit. It wasn't designed. And the way a crowbar circuit works is that when a voltage reaches above a certain point, it actually shorts out the output of the power supply and takes the output voltage down so that it won't damage your equipment. And at worst, it'll damage your power supply. Anyway, mine did that, and then what I did was fortunately it didn't damage too much equipment, but afterwards I went and I fixed the power supply and I added a crowbar circuit onto the output. So that might be good. One good thing to just watch out for potentially when you're shopping around.
What What power supply was it? Are you comfortable talking about that? Or?
This was a Dick Smith power supply, which was probably designed in the mid-90s. So it was a fairly long time ago. They were very reliable, but the only problem is that if one of the regulators failed short circuit, you would get something like 20 or 22 volts on the output, and one of the regulators short circuited one day. So
yeah, so I've seen videos on YouTube where folks would have switching power supplies that'll have over voltage runaway, and cook their equipment in there, and obviously none of them were very happy about that. But the idea of the crowbar circuit's pretty it's a pretty good one, right? And you can actually buy. We were looking at them the other day. You can buy crowbar circuits that you plug in line between your power supply and your power distribution bar, and that should be able to help you out. But they're around $150. They're expensive, but you could probably build one much cheaper. But you want to make sure you do it right. So a fuse is not always going to stop that, right? Because fuses are designed for overcurrent, not necessarily over voltage. So if you have that voltage problem, a fuse is not going to save your life or save your equipment or whatever you want to call it.
Yep. Yeah, but it won't, and as you say, it won't save it from over voltage, and that's where that circuit comes in. And sometimes it can be as easy as adding a transient voltage suppression diode, TVS diode, which you can get them at various current levels and also various voltage levels. And if you just pick one that's like around 14 volts and you put that directly on the output of your power supply, what will happen is that that'll go short circuit if it goes over 14 volts, and it'll short circuit your power supply, which is fine. It'll probably, your power supply might not like it too much, but at least your radios won't blow up. So. But that's probably getting a bit advanced now, past what we're talking about. But it's good to know. It's good to know, though.
Well, yeah, it is. I mean, so and our job is just to make sure that we throw as much education at the wall, so that when consumers are making choices, because just being honest, like when I bought my first power supply, the first parameter that I looked at was price. Right, I didn't look at linear versus switching, and then the second parameter I looked at was the amount of output amperage. And so I really didn't consider anything else. And so the more that you hear these conversations and the more you learn, the better informed you are when you end up making a decision. So like I've got an MFJ, I think it's a 25 amp switching power supply that I've had for probably, 8 years or something like that. And it's almost always on. And I only had one problem with it. The fan started making a bunch of noise. So I did a video where I replaced the fan in it. And I use it all the time. It doesn't really cause any noise or interference that I can detect. And it maintains good voltage levels and current levels. So, I mean, I like it. I did recently buy a used Astron power supply, and that thing's almost 30 years old. And it's got a few issues. It's not nothing that's show-stopping or anything like that. But I was taking a look at it. Inside of it, it's got a capacitor that's like the size of a beer can. I mean, it's huge. And one of the things that can happen over time is you get degradation of the capacitors, and they don't stay at that same value that they were before. And so a lot of these capacitors are used to do the filtering, and the filtering doesn't work as good as it should when the capacitors start to go bad. So I'm thinking about replacing that. And then it has a controller board inside of it, a regulator board, that I'm probably just going to, some people are like, oh, you can replace the components on the board, blah, blah, blah. You can buy a brand new board for it for $30. So I'm probably just going to switch the whole board out, which has some parts to it. I mean, it's got like 7 solder points or something, so it shouldn't be too painful. But I'll probably do that just to make sure that I have new components in there to not have to worry about any problems. So I have in here, ham radio often involves delicate communication and reception, especially for weaker signals. Linear power supplies are stable, and the clean output's beneficial for sensitive radio equipment. So you do sometimes get more fluctuation, and you also get that ripple stuff that we talked about earlier with the switching power supplies. That can be an issue. Almost every ham that I know uses a switching power supply, and they almost always use the lower end models just because they're price conscious. So it's funny because I was talking to Jim, and he has a switching power supply, and he was having problems with it where I think it was cutting off when he was transmitting on his flex. And I told him, I said, son, you need to buy. He was looking for other power supplies. I was like, you need to buy this 50 amp Astron. It's like a $400 power supply. He ended up doing it. And he's like super duper happy with it. I don't know if he's still watching or not, but the Astron actually has a 70 amp variable linear power supply that I want, but the thing's like $600, and I definitely don't have $600 to be spending on a power supply.
Yeah. Before we go any further, do you have anything about duty cycles for power supplies in here in your slides?
I don't think I do. So if you want to talk about it.
Yeah, so just quickly, you prompted me to think about it just then. When you're talking about output current as well, so, you can look at 40 amps, 50 amps, 70 amps, whatever. What do you really need? Well, for a typical HF radio, you're probably looking at something like 20 amps maybe. So I've got the IC 7300. And I think that draws about 18 amps transmit, which is the maximum amount of current that it's going to draw. And then I've also got an IC 9700, which is around about the same. So if I was to transmit on both of them at the same time, full power, it's about 36 amps. But I don't do that, and it's very rare. Yes, I did say duty cycles. So the power supply that I've got is a 30 amp continuous and 32 amp surge power supply. So what that means is that it can deliver 32 amps continuously at 100% duty cycle. So if you're shopping around and you're looking for your power supplies and you think, well, I need a 50 amp power supply to cover me for whatever contingency, it's not necessarily the more amperage. I mean, sure, if you want to get a higher power supply for more amps so that you can run more radios that might be drawing high amounts of current at the same time. But the main thing to look at is probably duty cycle, because you don't want to get a power supply that's only going to deliver you 20 amps but only for 20 seconds. You want to do it, continuously for at least a few minutes, especially if you're not so much on single sideband, because that's not going to be drawing 20 amps continuously. But if you're doing FM or you're doing digital modes or something like that, that does draw current continuously, you don't want your power supply to blow up. So,
yeah, well, it's a great point. So, like, if you have a radio that requires 20, let's just say 20 amps to make the math easy, when you're transmitting at 100 watts. So if you're transmitting FTA at full power, you're pulling 20 amps. If you're doing single sideband, you're probably pulling 10 amps. It's about half of the, I think the ARRL calls it duty factor when you figure in your power requirements. But that's because the modulation that's going back and forth with the inflection in your voice requires different levels of current to do that.
And it's pretty cool, actually, if you watch it on an analog meter too, because if you've got an analog meter power supply and you talk, you see the current meter doing this on your voice peaks.
Right, right.
Yeah.
So yeah, it's a good point and something to definitely think about. I typically tell folks, if you're going to be using 100-watt radios, you should target around a 25 amp power supply. And the reason I say that is I might be playing FT8 and I'm drawing the bulk of that current, but maybe I've got my dual bander on because I'm monitoring local repeater. I've also got, your SWR and power meter, which draws current, not a lot, but it draws current. And then you have a tuner thrown into the mix, and sometimes you have different components and things. And what you don't want to do is buy the power supply that just barely gets the job done and then get another piece of equipment that you want to power, and now you have to go out and buy another power supply. Because you're going to end up paying more, but you're going to have two smaller supplies versus one larger one that gets that job done.
Yeah, that's why I've got a 30 amp, and I've also got another power supply. It's a 40 amp, so I'm good and covered.
The linear that I got is a 35 amp, which is I wanted 50 because I like to overspec everything, and I never run anything at full load anyway. I'm not out of practice. I'm not one of these floor type guys.
All knobs to the right.
right. Some people turn everything up full power. I don't do that.
Oh, plate voltage. Let's turn that to the right.
right. What I have here is linear power supplies have a pretty straightforward design, making them easier to troubleshoot and repair if needed. And that's awesome because, like I said, the one I bought's like 30 years old. internally it looks just like the brand new ones, and you can still buy the parts for it that they're still using for the newer versions, and it's relatively easy to fix. Switch mode power supplies aren't overly difficult to work on, but they're more complex than the linears.
Yeah, linears are they're pretty easy to repair. You're definitely right, and they're pretty much, it's all pretty much the same basic design as well. It's just thumping great transformer with a couple of capacitors, regulator board, and then maybe some fusing and maybe some filtering, and that's about it. So some switch mode power supplies can vary a little bit depending on what chips they use for switching voltages, how they've designed it, because switching power supplies, which I'm sure is your next slide, is they're designed for efficiency in mind. Linear power supplies are not. So
no, they're not. So linear power supplies, and it is on the next slide, generate a ton of heat, and so that's one of the ways that that that's energy being dissipated as heat as opposed to energy going into your equipment. But what I have here is in the case of additional filtering, if it's required, it's relatively simple to add extra filtering components to the linear power supply with so you can further reduce any noise or problems that you're having there. Tons of schematics online if you wanted to go out and look at linear power supplies and get an idea of what we're talking about. So I did have the bad. There's some things that you need to consider around linears as well. First off, there are I don't think I have it on here. Oh, that's the last one, so I'll wait till I get there. Linear power supplies are less efficient, so we were just talking about that compared to switching power supplies. And switching power supplies kind of turn off, turn on, turn off, turn on, turn off, where linear is just constant on. And so that's one of the reasons why they're less efficient, and one of the reasons why they generate all that heat. They waste more energy as heat, especially when there's significant voltage drop between the input and the output. And so that would be if you're taking 110 volts in and you're dropping it down to 6, you're going to have more energy and heat used than if you're dropping it down to, say, 24 volts or 12. And this says this efficiency can lead to higher operating costs. Linear power supplies tend to be larger and heavier, and boy, is that true. That 35 amp that I got, I mean, that thing probably weighs 45 pounds, but that's because the transformer in it is this big monster chunk of iron. I had to carry it down to the basement. I almost blew out my O-ring. I'm telling you, man, that was
Is your O-ring what I think it is?
It is. I was like, I hope I don't sneeze. I hope I don't sneeze while I'm carrying it.
Nah, she's full.
Right? It's like, so we got that. That's gonna leave a mark.
Yeah.
So you just got to be careful there.
So you won't blow the shorts off. Yeah.
Right. Linear power supplies tend to be larger and heavier. We discovered that when linear power supplies typically have a limited input voltage range, which means they might not be as versatile for different locations or power sources. That's probably a little bit outside of ham radio. People use power supplies to do all kinds of stuff. Like I know folks who do construction work, for example. So they take like these, they use mostly battery power, but and to power different tools and inverters and stuff like that. So I don't think that is. I mean, most of our input is mains voltage, which is pretty standard, right? So it's probably not applicable. Due to their lower efficiency, linear power supplies generate more heat. Adequate heat dissipation is necessary to prevent overheating and potential damage to power supply and connected equipment. So that's where when you take any power supply, make sure that it has good ventilation. Sometimes they have a fan on them. You want to make sure the fan's clean. You're not getting dust built up on the fan input or output inside the power supply. You don't want that to happen. But like the linear power supplies have these big old heat sinks on the back of them. They mount a lot of their components directly on those heat sinks to keep the components cool. So what you don't want to do is like jam that thing into a bookcase where there's no circulation or air movement, where that heat is just going to build up and it's going to eventually fry your components out.
Yeah, and the like we said, there's pros and cons and everything, but the con with linear power supplies, especially if they overheat and they don't have if the fan fails or if there isn't proper heat sink on the back of them, which most of them do because they've got this design in mind, is that you think about them constantly heating up, cooling down, heating up, cooling down, heating up, cooling down
Right.
over a long period of time, over years and years and years. And then your PCB boards in them, the solder joints crack, the solder joints get dry, the components they overheat and they fail. So whilst I don't have any particular evidence to say that linear power supplies are better than switch mode power supplies as far as failure rate are concerned. Probably switch modes are slightly more prone to failure because there's more components in them.
Right.
But linear power supplies, as long as they have that heat dissipation and they're not, as you say, jammed up with no air to move around, they'll usually give you many years of reliable service for a decent supply.
So help me understand this question. It just popped up. So 100 volts VA is only, I don't know if he's saying 100 volts there. I think he's talking about amps, right? I'm not 100% sure what you're asking, Shane. I'm sorry.
VA is 100 VA is a power is not a power. Sorry, it is a power measurement. Yeah. 100 watts RF needs a lot more electrical power than 100 VA. 13.8 volts at 30 amps is over 400 VA. So 100 watts RF it's because of the it's not very it's because of the efficiencies in the radio. So they're not so if you have, say, 13.8 volts at 10 amps current draw, you're not going to get 138 watts out RF wise, if you know what I mean, because not everything's going to be running at perfect 100% efficiency. So you're going to be a lot less because of that, because the conversion from output power to RF is going to lose quite a bit in that process.
Well, the radio takes a tax, right? The radio takes a tax because your radio gets hot, so you have heat and loss there, but you know, you're powering your display and you have components in there that take power to run, right?
Yeah. Yeah, and I mean, VA, that's something that I learnt probably 15 years ago and I've forgotten about it. So
yeah, I'm just not familiar with it.
That's electrical speak that I don't really use in amateur radio, or don't need to use. But
so we got an educated man.
Should learn about it again though. I should definitely learn about it again though.
And so the last one I have on here is linear power supplies can be more expensive than switching power supplies of comparable output ratings, especially for higher power levels. And I'm assuming the bulk of that cost is actually in the transformer, not so much in the raw materials. There takes a lot of copper wrapped around those things, but also it's a big iron block. But that's one thing I wouldn't want to do, is have to rewind or wrap a transformer for a linear power supply. You'd want to buy a pre-wrapped one, I would imagine, because that would be a job.
Mm.
Hey, Hollywood. How you doing, buddy? Hollywood's here. So the next thing we have is the good of switching power supplies. And what I have on here is that switching power supplies are known for their higher efficiency. I think we covered that already.
Yep.
Especially when there's a significant voltage drop between input and output. I think we covered that as well. They waste less energy.
And did we briefly say why they're more efficient? I think we did.
Yeah, well, we talked about the on-off versus the constant on, right? That's right. Probably the biggest thing. But as a result, they waste less energy as heat, and they don't need to be cooled off as much, which leads to a lower operating cost and reduced heat dissipation requirements. So you can jam them in the bookcase. Still make sure you have plenty of airflow around them, and don't clog up the fans or anything like that. But it's less of a concern. Due to their higher efficiency in switching operation, the switching power supplies can be designed smaller and lighter than power supplies with similar power ratings. This makes them ideal for portable and space-constrained applications. Now, I have a 45 amp switching power supply from MFJ, and it's good. It's a good size. It's pretty big, but when you open up the case, it's got a lot of empty space in there. It definitely could be shrunk down, but it probably weighs around 8 pounds. To the 35 amp linear that I've got is probably around 45 pounds. A significant weight difference there. The other thing is like if you take a heavy linear and you put it on a shelf, make sure the shelf can support that much weight. Right? You don't want that to come tumbling down, especially when you're asleep and you think somebody's
Yeah.
breaking in.
Hang on, when do you ever put your power supply over your bed?
Well, I mean, I have it's not over my bed, but I do have a smaller ham shack in my bedroom. Right, so
Oh.
I've got.
Oh, jeez. You've lucked out there with the permission to have the smaller ham shack in the bedroom.
Well, we have a desk in there, and so in there I've got a smaller. There's a 25 amp switching power supply. My Sun SDR, which is small, right? So it's like it doesn't take up a lot of space. And
I thought when I heard you say that, I thought that you had a son and he's called SDR. For a minute then.
oh man, I got the Sun SDR DX too. And
Yeah. Now I've worked it out. You're not that you've got a son called SDR. Sure.
So here we go. Anyhow, she's Hollywood saying, "Does your power supply lose its flavor on the bedpost overnight?" So I do have like a small bookcase on my side of the bed, and dude, there's multimeters and NOVNAs, tiny SAs, and HTs and stuff sitting there. And so like a lot of times I'll be at night, like on Discord or something like that. And let me check that real quick with the tiny SA, or and it's my wife is a saint for putting up with that kind of crap.
Especially if there's a Baofeng on that shelf as well.
There is a Baofeng on that shelf.
There you go.
Where's my Baofeng? Oh, so stupid. All right, I just do dumb stuff like that. I'm sorry, But like, I've got a multimeter. Who in the world has a nightstand multimeter? But you never know, man. Might need to check something.
Yeah. Yep. You might need to grab that at 3 a.m. in the morning to test something. So.
Right. Well, we had a power outage here during an electrical storm a few weeks back, and it was hot. So it was like immediately started getting hot, and I'm like, I've got all these 100 amp hour batteries that I'm always testing and stuff like that. So I ran down to the basement, grabbed 2 of the batteries, and my inverter, ran them upstairs and set everything up. Powered on the TV that we have in the bedroom, along with a couple fans, and then I used my cell phone to connect to the cell tower, which was still powered up. So I had internet, and we were watching Netflix. Everybody else in the neighborhood sitting in the dark, but I've got Netflix. I got my fan going. I was loving life. It's ridiculous.
Yep, mate. You should have been on the radio at when the power goes out across the neighbourhood. That's the best time to get on radio, right?
Yeah, well, we were still having
HF.
electrical storms, so I had my antennas on. Just,
okay.
It didn't want to get lit up.
Yeah. Fair enough.
Now, a few years ago, we had a really bad power outage in the neighborhood, and we took my neighbor's golf cart, and because he's got all the batteries in the golf cart, and we wired that up to a.
Did he know about it?
Yeah, he knew about it. We were at his house. So we wired it up to a space heater because it was actually really cold at that time to warm up in the garage. And then we had the TV going so he could watch football and stuff. And we had his DirecTV satellite dish connected to it. So we were getting satellite TV, heat, and TV. And then the women folk found out and immediately infiltrated. They brought all the kids over. And the game got turned off, and we had to watch like Paw Patrol or something like that.
And then poor your old mate couldn't go back and play his golf game the next day. He had to go and get a caddy to walk around.
To charge it. Yeah. So we have the switching power supplies can be designed to provide various output voltage levels easy, making them more adaptable to a wide array of electronic devices. Now you can get variable controlled linears, but almost every switching that I've seen has got variable control on it. It's just a much more common thing. And then I've actually got a desktop power supply that you use for like electronics work. And that goes from like 0.001 volts all the way up to 30. And it was only
Just be
like
extremely
$65.
careful. Yeah, just be extremely careful running those because most of the ham ones will have an override switch which will lock it at 13.8 volts, and it doesn't matter if you move the knob on the front, it's not going to change the voltage. But some of those lab supplies, they don't have that, so you don't want to be, you know, working away and your radio's on and you bump the knob and you've got all of a sudden you've got 25 volts on your radio. So you just got to be careful with that.
Yeah, so my lab supply, I've never used that to power a radio except for today when I did a video. It was the first time I've used it for that. I typically use it just to power devices and stuff like that. Let's see what we have here. The higher efficiency of switching power supplies results in less heat. I think we covered that, which can contribute to improved reliability and extended lifespan of the components. But to the point Hayden was making earlier, they've got more innards in them and more parts and switching parts and stuff like that can wear out faster. At higher power levels, switching power supplies can be more cost effective than linear supplies, considering their efficiency and reduced cooling requirements. So here's the bad for switching power supplies. They operate at high frequencies, which can introduce electrical noise, RFI, and different interference we talked about. I think sometimes we call that EMI, like electromagnetic interference. All RFI is electromagnetic. All RFI is electromagnetic interference, but not all electromagnetic interference is RFI. I think I said that right.
I think so.
While they're generally more efficient, switching power supplies have slightly higher output voltage ripple in noise compared to linear power supplies. Maybe we'll do that one day on stream. We'll actually do some testing. The actual test the ripple, you got to be able to capture the power as it's coming right out of the final stage. That's not the back of the radio. I mean, you can measure it that way. There's various ways to measure it, but like the lab, like the way that the nerds do it, that test is actually pretty difficult to pull off. But you know, maybe we'll do that on stream or something. They have more complex design, and I think that's what you were talking about when you're talking about all the parts, than linear power supplies, involving more electronic components that control circuitry. So that's like the chip and stuff like that. That makes it more difficult to troubleshoot and repair. Like the Astron power supplies is basically like Lego. So if you think something's bad, you call Astron up, and they'll just send you the components, and you just yank and repeat. It's pretty easy. The switching power supplies, you're gonna have to break out schematics and test and stuff like that. Here we go. The high frequency switching can result in electromagnetic interference, and radio frequency interference, RFI, which could potentially interfere with nearby electronic devices or equipment. And so that's why, like I was talking about the server power supplies, and that's always a hot button issue. But like some of the ham radio power supplies, I think we mentioned, have a tuning capability, so you can move that frequency around if it's causing you any problems. But the folks who manufacture them know that they're going to be used for amateur radio, and so they make sure to put as much filtering as they can. That's not cost prohibitive or anything like that. So you get something that's purpose-built versus something that's not purpose-built, right? And anything that's purpose-built generally has better design specifications, and you'll have less problems there. Some switching power supplies may exhibit poor voltage regulation under certain conditions compared to other power supplies. And that's not so much a problem if you buy something purpose-built for amateur radio, but I was talking about it a little bit earlier. When you put a load on a power supply or a battery, you'll typically see voltage sag. And what'll happen is that your supply has to catch up to get back to the voltage that you want to operate at. Fluctuations in voltages are not good for sensitive electronic equipment, right? They can cause problems. They can cause things to burn up. They can cause things to fail. And you don't want that. So you want to be able to deliver. Amperage is not as big of a deal, but you want to make sure that you maintain your voltage as close to true as you can when you're operating. I don't know if you got anything you want to add there, Hayden.
That'll be specified as well on the power supplies specifications, that when the power supply is at full load, in other words, you're drawing the maximum amount of current out of it, how much the voltage is expected to sag. Now, that's off of the power supply as well. Sometimes you'll notice that your radio might if you've got a voltage measurement on your radio, or if, for some reason your screen dims or something like that, that might indicate an issue more with the cabling between the power supply and the radio, because sometimes fuses can go high resistance and you can have bad connections, and you need to check all of your connections again. May not necessarily be the power supply dropping its voltage. So when you do check that. Just check your output voltage of your at the power supply and see what it is. But in most cases, I think that the voltage shouldn't sag any more than 5 or even maximum 10% at 13.8 volts, which is only
I've seen it
only
sag,
a volt or so.
Yeah, I've seen it sag more than that with batteries versus like switching power supplies and stuff like that. So that's another.
Yep.
I know we're not talking batteries, but you make sure that you're using good quality batteries that can handle that sag.
Yeah.
So our friend Hollywood, he's talking about Ripple and regulation. And before I got in amateur radio, I thought Ripple was just something you drank on the weekends. You probably don't have Ripple down there, but
No.
it's like a $3
Sounds
bottle
good though.
fortified wine. It's it's a grape juice with like distilled spirits in it that they call wine. It's like super duper cheap, and people get loaded on it all the time. You might call it swish down there. I'm not 100% sure. I think that. And G0 FVT is making a good point there. So we have some switching power supplies. We covered that one. And then at lower power levels, the cost advantage of switching power supplies diminishes, and they may become more expensive than linear with similar ratings. And so I think that you see that variation in price, the more precision or precise something needs to get, right? It requires more engineering and better quality components with less variance in them, right? When you talk about the plus or minus percent, maybe you're looking at lower variance components. And that's my last slide. So I'm gonna go ahead and remove that. And so we talked about potentially going and taking a look at some power supplies on the internet, but I don't know. We've got 8 minutes left, so I'm not 100% sure.
We can do it. Let's do a quick thing. Let me go. You wanted to go to DX Engineering, did you?
Yeah, they have one of the easier amateur radio websites to navigate.
Okay, here we go. I'll share my screen. Excuse me.
That's funny, 45.
All right, there we go. So here's, I mean, I don't really know most of these brands, but
Samlex is
you'll know
considered. This. Yeah, Samlex is a really popular, respected brand.
Yep. So this is and again, desktop switching supply. Oh, nice analog meters on them though. But I think just to skip through some of these, Elenco would be pretty good, reputable brand, yeah. MFJ as well. Astron's like the gold standard, right?
Yeah, but that's a switching. So like I was mentioning, Jim got the 50 amp linear Astron.
Yep. So something like this. So this is a linear supply. So you can see that the price does go up because this is a 35 amp. And if you scroll back up to, where was it? This one's a 50 amp, and they're around about the same price. But obviously the switching power supply can deliver more current than this one. But the switch mode supplies, the linear supplies going to be a lot heavier and, probably going to be a little bit better as far as RFI is concerned and all the other bits and pieces that we discussed earlier. Right.
So that's the one that I bought, is this Astron VS series. So you can see the knobs on the front, so you can adjust the it's variable in terms of amperage and voltage. You can adjust that. And that thing, man, is heavy. I'm just going to say it again.
For some reason, I can't switch. Let me just do this instead.
And they'll have different connectors on them. Like some will just have posts, like bolt posts that you can use. Some of them, like this one here in the front, has Anderson power poles that you can use. A lot of them will have the 5-way posts, where you can put like a BNC, or you can put like a ring terminal or something like that on them.
Oh, look at that. Regulators bolted to the transistors bolted to the outside.
Yeah, that's how mine is. So they're bolted right to that heat sink to keep them cool. Now, one of the things I don't like about it, go back to that last picture, is that you can, right here, you can see that one, the positive and negative terminals there. I like to see a little bit of a separator between those, just in case you have an oopsie so that you don't cross streams, as they say. And
Cross swords.
yeah, I think that's kind of a big thing. The other one is that with these out, they're hot, right? So when you're running current through there, they're hot, and you could, if say you bump that into a metal cabinet or something like that, you could get a short.
Holy moly, this is fancy.
Yeah, look at that. You don't got that kind of stuff down in Australia, do you, boy?
No, that's DX Engineering's fault. They won't open up a store down here.
We should talk to Tim.
We should. I noticed that this has also got current limiting, so you can actually reduce the maximum amount of current as well, which, why would you do that? It's mainly for like lab supplies, like the ape said that he used before. Sometimes you might have a circuit that you're building, or you might have a piece of equipment, right, that you want to hook up, but you don't know if it's working, and you also don't want to blow it up, because if you say stick it on a power supply that's good for 30 amps, you might blow it up. So you reduce your current, the maximum amount of current that the power supply will deliver, and then you just gradually, turn that up until you realise, hey, this thing's not supposed to be pulling 10 amps. I guess in some regards too, you could use that in a pinch to charge a battery if you wanted to as well. You can reduce the amount of current that you're putting into the battery. Because if you hook up a power supply with no current limiting to a battery to charge it, it's just going to pull maximum amount of current until it gets to a point, and then it's going to reduce down, which is not really good for both the battery or the power supply.
Yeah, and Anime is asking what would be the lightest weight portable RV power supply. It feels heavy because it's small. It's like jam-packed with components, but I have an MFJ. It's the 4230 DMP, and it's super duper tiny, and I like it a lot because it's small and lightweight there.
Yeah, some of these, like this little Yaesu, it looks very similar design to another one that I've got, and they're pretty lightweight as well. Right. And the other
that's
thing
the
too
one
is
I want right there.
that big thumper.
The one below it, the VS series. That's the one.
$600. How much money are you earning, son, to buy that?
I was saying earlier, I don't have the money. It's the one below that one. It's the VS series. Linear power supply.
Even worse.
So that's the one I put on the thumbnail for the stream. And
yep.
Ooh, would I love to have that?
Oh, the rack one.
I don't have a rack.
See, that power supply there would be good for repeaters, right? So because you can mount that directly into a rack and bolt it in. One thing that was mentioned just a minute ago, which has just flown out of my head, was it around the weights? I can't remember. Anyway, continue, and I'm sure it'll come back. No, it's gone. It's gone. I can't remember. But you can see that the prices are going up exponentially as you start to get into some of these. Yeah. Oh, now I remember. So we talk about RFI and noise and all that sort of thing. So sometimes these smaller switching supplies that, are a bit more budget friendly, these will be perfectly fine for running your dual bander at home, because you're not likely to be receiving any interference or RFI on your FM dual bander. It's pretty low. It's only when you're talking about HF is when that becomes a real issue. So
yeah, good point.
That's why there's such a wide variety of suppliers on here for different reasons.
Gary's not a fan of MFJ.
I thought it meant something else, but
well, yeah, that's what he's saying. So there's the I have that one, that 4245. They actually sent it to me. And that's what Jim was using, an older one of those that was giving him some grief. I've also got the 2245, I think is what it is.
Yeah. So as you can see, this is a stack of different, look at this, there's 9 pages of power supply. Are they all power supplies? Jeepers. So there's so many options that you've got, but hopefully we've covered enough to help you make an informed decision when you're purchasing your next power supply. So
yeah, and if you have questions, you can reach out to us directly. I think both of us have our email addresses on our channels. Or comment on the video, even better. Yeah, you could do that too. So we just hit the hour mark, and I think we were slated for an hour. So what I'm going to say is thanks to everybody for watching. Totally appreciate it. Thanks for the engagement in the chat. Much appreciated again on that. And I'm going to go ahead and I'm going to hit the end broadcast button. You want to say goodbye real quick, Hayden?
Yeah, thanks for having me on, Ape. It's been good learning about power supplies, and hopefully you guys got something out of it. I know I did. And we do need to close out, though, with something for... who left it in the chat? Was it
Chrissy?
Chrissy. So we might do that on the way out. So,
All right, well, you fire it up and I'll hit the button.
all right. See you guys.
Later, thanks. Uh-oh, you're going to get me banned over here.